Welcome students to ASHISH Singhal #maths. In our previous episodes, we have seen that we have done chapter 1 of class 10th. So dear students, today we are going to start with the chapter 2 polynomials. In your previous classes, you have studied about the degree of a polynomial. X plus 2 is a polynomial whose degree, the highest power is 1, so its degree is 1. If you have x square plus 2x plus 3, this is a polynomial where the highest power is 2, so we say the degree is 2. Like this, if there is a polynomial x cube plus 2x plus 5, in this case the highest power is 3, so the degree is 3. This is called as a linear polynomial, this is called as a quadratic polynomial, and when the degree is 3, it is called as the cubic polynomial. Now students, if there is a quadratic polynomial, there can be two type of graphs. It is a parabola, either it is facing upward or it is facing downward. Now, suppose the polynomial is ax square plus bx plus c. The face of the parabola, whether it is facing upward or whether it is facing downward, depends on the value of a. If a is greater than 0, then the parabola faces upward. If a is less than 0, then the parabola faces downward. You must know this because there are chances of getting 1-mark question based on this. Secondly, precisely wherever the curve cuts the x-axis, wherever the curve intersects the x-axis, we say that so many solutions are possible. Like in this case, the curve is intersecting the x-axis at two distinct points, so there are two zeros or two solutions. If there is a curve which doesn't intersect the x-axis, we say that it has no zero. If it intersects or touches the x-axis at a single point, then we say we have 1 0 of this polynomial. So students, in the first exercise, we have exercise 2.1. The graph of y is equal to px are given in a figure 2.10 below. For some polynomials px, find the number of zeros. See the first case, the line is not touching the x-axis, so it has got 0. Number of zeros are 0. In second case, the curve is cutting the x-axis at single point, it has got 1 0. Third case, the curve is intersecting the x-axis at 3 points, so there are 3 zeros for this polynomial. Fourth case, the curve is intersecting the x-axis at 2 points, so it has got 2 zeros. Fifth, it has got 1 2 3 4 zeros. In the sixth part, 1 2 and 3, so there are 3 zeros for this polynomial. So students, you have seen that the number of times a curve cuts the x-axis, so many zeros are possible. Now we are going to study relationship between zeros and coefficient of polynomial. If there is a quadratic polynomial ax square plus bx plus c, let alpha and beta be the zeros of this polynomial. Then sum of zeros, which is alpha plus beta, is given by the formula minus b by a. Sum of the zeros, which is alpha plus beta, is given by minus b by a, and product of the zeros is alpha into beta is given by c by a. So these are two important relations to find out sum of the zeros and the product of the zeros. Now, if the question reverses, if sum is given as P and product of the zeros is given as Q. If sum is given as P and the product is given as Q, then what is the polynomial? Then the polynomial will be K times x square minus sum of the zeros into x plus product of the zeros. X square minus sum of the zeros into x plus product of the zeros, or we can write, if sum is P and the product is Q, x square minus px plus q. So students, based on these two concepts, we have the next exercise with us. So let us start solving exercise 2.2. Find the zeros of the following quadratic polynomials and verify the relationship between the zeros and the coefficients. So in this question, we have to first find out the zeros of the quadratic polynomial, and then we have to verify the relationship between the zeros and the coefficients. So first question, first part is x square minus 2x minus 8. Try to split the middle term. Here the sum we need is minus 2x and the product we need is minus 8. So that means we have to split the middle term as minus 4x and plus 2x. So x square minus 4x plus 2x minus 8. We take x common from the first two terms and 2 common from the next two terms. So we get x plus 2 into x minus 4. This shows that zeros are minus 2 and 4. So zeros are minus 2 and 4. Now we need to verify sum of the zeros, minus 2 plus 4, which is 2. And the formula to find out the sum is minus b by a. So we find out minus b by a. If you see the question, a is 1 and b is minus 2. So we get minus b by a is equal to minus times minus 2 by 1, which is 2. So we have verified that sum is equal to minus b by a. Similarly, we will verify the product. The product of the two zeros, minus 2 into 4, which is minus 8, and we also find out c by a, that will be minus 8 upon 1, which is minus 8. Hence, students, the product is verified as c by a. So in every question, every part, you have to completely verify and solve the question. Now in the next part, I am going to solve the question where verification you will be trying yourself. Second part, 4s square minus 4s plus 1. Split the middle term, 4s square minus 2s minus 2s plus 1. So this gives you 2s common, 2s minus 1 common, 2s minus 1. So students, we get 2s minus 1, 2s minus 1 or 2s minus 1 whole square. So the zeros are 1 by 2 and 1 by 2. Zeros are half and half. Now you can verify in the similar pattern as we have done the previous one. Moving on to the third part, which is 6x square minus 3 minus 7x. Let us rearrange it first. So we get 6x square minus 7x minus 3. Splitting the middle term, we get 6x square minus 9x plus 2x minus 3. Let us take common from the first two terms. So 3x is common. So we are left with 2x minus 3. Here also we take 1 common, 2x minus 3. So we get 3x plus 1 multiplied with 2x minus 3. So the zeros are minus 1 by 3 and 3 by 2. The verification, students, you can do it yourself. Now moving on to the fourth part. 4u square plus 8u. Take 4u common, so you get u plus 2. So the zeros are 0 and minus 2. Fifth part, t square minus 15. A square minus b square identity will give you t plus root 15 multiplied with t minus root 15. So the zeros are minus root 15 and root 15. Students, verification, you can do it yourself. Last part, 3x square minus x minus 4. Let us split the middle term. 3x square minus 4x plus 3x minus 4. Taking common, we get 3x minus 4 into x plus 1. So the zeros are minus 1 and 4 by 3. So in all these questions you have seen that we have found out the zeros, and then verification you can do it. Question number 2. Find a quadratic polynomial each with the given number as the sum and the product of its zeros respectively. So here the sum and the product of the zeros is given, and we have to find out the quadratic polynomial. You already know we have done the formula. The formula is x square minus sum of the zeros into x plus product of the zeros. So here the sum is given as 1 by 4, product is given as minus 1. So the equation, the polynomial is x square minus sum of the roots 1 by 4x minus 1. So we can check the LCM. So this will become 4x square minus x minus 4 upon 4. So this is a polynomial. We can write the polynomial 4x square minus x minus 4 also. Second part, the sum is given as root 2. The product is given as 1 by 3. The polynomial will be x square minus root 2x plus 1 by 3 into k. So we can take LCM. So this will become k by 3, 3x square minus 3 root 2x plus 1. Third part, the sum is given as 0. The product is given as root 5. So this is k times x square minus 0 plus root 5. So we can rewrite this as x square plus root 5. So this constant we can remove from the polynomial. There is no problem. Sum is given as 1, product is also given as 1. So the polynomial is x square minus x plus 1. The fifth part, minus 1 by 4 and 1 by 4. So x square minus k also we write minus 1 by 4. So that makes it plus 1 by 4x plus 1 by 4. If I take the LCM, k by 4 is out. 4x square plus x plus 1 or 4x square plus x plus 1. The last part, where the polynomial is given as, sum is given as 4, product is given as 1. So the polynomial is k times x square minus 4x plus 1 or x square minus 4x plus 1. So students, this is the way we have to solve question number 2, where sum and the product is given to us. I hope you must have understood the exercise 2.1 and 2.2 of the chapter polynomials. So next time, in the next lecture, we are going to take up quadratic cubic polynomial and also the division algorithm for polynomials. Subscribe to our channel for more inputs. ASHISH Singhal #maths. Thanks for watching.